Aloha and welcome to the video on the properties of water. Today's video goals are to explain why water molecules are polar, and also we'll name and describe some of the properties of water. Okay, so we're going to start off with a real quick talk about the molecular structure of water. If you look down here below, what you'll notice is that molecule of water that we recognized when we were talking about covalent bonds. And in covalent bonds, remember, they share the electrons. So between our hydrogen and our oxygen, we have these shared electrons. Now, even though they're sharing, these electrons are going to spend a little bit more time down here on the oxygen atom than the hydrogen atom. And as such, that results in a slightly positive charge on the hydrogen atoms here. Because the electron's a little bit more away and that proton's exposed, it gives it a slightly positive charge. Now, because these electrons are spending a little more time down around here, orbiting around the oxygen atom, it gives us a slightly negative charge down here. And because we have a positive on one side and a negative on the other side, we call that a polar molecule. And polar molecules are kind of neat because they are able to pull apart ionic compounds, but also it sets us up for what we call hydrogen bonding. So because this hydrogen is slightly positive and this oxygen is slightly negative in nature, remember, opposites attract, and those two are going to kind of hold on to each other in a weak bond. But if we get enough of them there, then we can kind of see how water has some unique properties because of this. So because water has a unique formula, it gives it a bunch of unique properties as well. One of them is this idea of large capacity to hold heat. What that means is it takes a little bit more energy to heat up the water molecules and make them to move apart, so they store that heat energy there. But then they also take a longer time to come back down in temperature. So that works a lot of times as a buffer, or it keeps the milder conditions. So if you lived on an island surrounded by water, you would notice there weren't such drastic temperatures, and that can make for a milder climate. Now, the reason is because of these hydrogen bonds, which we talked about in the earlier slide, so we don't need to go through that one. But this one here is key, is the fact that water expands as it freezes. In fact, at about 3 degrees centigrade, water expands real quickly. What makes that unique is that means that the solid version of water, or ice, has a lower density than the liquid form, which is the water. And that plays an important part if we think about like a pond or something of that nature. If that pond is sitting there and it has water here, and then in the wintertime it freezes, what it does is only the top part of the pond will freeze over and form ice. And that means that the little fishes down below are able to survive through the winter. And that's kind of a really interesting thing. And that works out really nicely. And you can try that on your own. Take a bottle of water and then stick it in the freezer, and you'll see that the bottle misshapes because of the pressure of that expanding water. And then finally, we talk about water being a solvent. And that means a lot of things like to dissolve into it. We're going to cover these two words quite a bit. This philic here means that it loves it, and this hydro means water. So these ones here are water lovers. Okay, and that means those are compounds that are going to love to dissolve into water, things like sugar, things like salt, things of that nature. We can also have a phobic, which is a fear of water, and these ones here are water haters, and those would be things like oils that just don't dissolve in water at all. Okay, well, that's it for water. Good luck with the lessons, and we'll see you in the next video.